Hi guys, thanks for coming along to today's TDD session. I'm Olaf and I'll introduce myself through a slide in a little bit. So let me just share my screen. We're going to do a bit of TDD today. There we go. No, not that. This is what I want. I'm going to close that up. Alrighty. So I've called it TDD in a nutshell with an example. I imagine it'll take about, I don't know, maybe half an hour, maybe a little bit longer. And then I also thought if there's, if you guys have any questions, we'll talk about questions. If you want me to look at any code or do anything else, or get some other questions, we'll talk about that to use up the hour. For me to help you guys in whatever way I can, if I can. All right, cool. So let me just kind of get into this. Just a little bit about myself. So I've been doing this for 25 years. The slide is actually a little bit old. It is incredible. It's nearly 30 years. Okay, I mean, it's depressing, okay, age-wise, but it's good because I've got a lot of experience, especially around the sort of idea of writing clean code, clean architecture. How do you partition software well so that it's easy to change? And I've got a website, CodeCoach.co.nz. And you can see in the blog area there, you can subscribe to my newsletter. You get a little PDF, about 20, 30 pages long, Road to Master Programmer, that contains 3 ideas that I think are really powerful. They can get you to being an experienced senior developer in hopefully shorter than 30 years that it took me. Probably 5 or 10 years. You still have to have some experience. It doesn't happen overnight. You got to go through some of the pain, but I think it can be short-circuited in a lot of ways. And there's also great articles there on how to write better software. So it's not about any particular programming language, but it's more around the sort of information that is timeless on better programming. Alrighty. Let's carry on. All right, well, straight into it. So do a little bit of an intro on TDD, and we're going to get started with the 3 rules of TDD. So rule number 1 is only write production code to make a failing unit test pass. It's that idea that really forces you to, this concept that really forces you to write your unit tests or a unit test before you get to write any production or implementation code. All right. So you have to have some test code, and that test needs to fail. And that failure is what forces you to then write some production code, which will make the unit test pass. All right. And a compilation failure, like we'll see in C# shortly in the example, is also a unit test failure. Okay, rule number 2 is only write enough of a unit test to make a test fail. Sometimes, and I'm sure you guys have come across this as well, you sort of see unit tests that are really long, and it's like lots of setup and it tests lots of things, after the action, and that's just kind of too much. We really want to have sort of a thin sliver of unit test that just extends our production code a teeny tiny little bit. But if we do this often enough, over a long enough time, we do actually end up with a fairly powerful class or unit of classes, sort of a number of collaborating classes that work well together and actually do something productive. But initially we just sort of start with hardly anything at all. Rule number 3 is only write enough production code to make the failing test pass. So rather than writing a lot of production code, we just write a little bit of production code to make the failing unit test pass. So the unit test itself is really small, and the production code that makes that unit test pass should be similarly really, really small. At times that can mean just like a constant, if an int, number 3 does the trick, okay, great. If it's a string literal, then okay, cool. Let's just use that. We then use subsequent tests to make our production code more generic, so it can, handle any kind of money amount, just 3, or handle any kind of customer name, not just Fred Flintstone. All right. So it's on subsequent tests that we make the code more generic. And the second slide is the iterative process that kind of goes with TDD, where we start with the failing test. So that's red. Oftentimes in our IDEs, the failing unit test shows up as a red test. Okay, so that's the red here in the traffic light. We then write the production code as per rule number 3, just enough production code to make the test pass. So now it turns green. And then, oh, that's a little bit hard to see. I'll just move that up here. And then we refactor in step number 3. The refactor step doesn't get enough attention. It's actually, it plays very little role when you start out, because there isn't anything to refactor. But as the production code and also your unit test code becomes more extensive, it now pays to refactor both of those. The test code as well as the production code should be refactored to make it simpler, easier to read, easier to understand, faster if need be. Okay, but really at the end of the day, sort of more maintainable and really sort of crystallize through the unit tests what it's all about. And with the production code, make that simpler so it's easier to understand, easier to read, and easier to maintain. And then we kind of go around and onto, make either extend the current unit test with another condition, okay, extend it a little bit. So it turns red again because now we've extended it a bit with another, say, verification or assert, or we write a new unit test that now is breaking. It's red, is failing, and we need to make that pass. And that sort of iterative loop should take very little time, maybe on the sort of order of a minute to maybe a few minutes if you got stuck. And the beauty is, if you get stuck at any point in time, you should just be able to go Control-Z, undo, 3, 4, 5 times, and you're back to the green state where everything was working. Are there any questions? Or so far so good? All right, I'll carry on. Okay, and the example that I wanted to do today is the FizzBuzz problem. I don't know whether you've come across that before in an interview. I've faced it at least twice in an interview situation for a job. It's not the only place where it shows up. Sometimes it's just given as a little fun example in a hackathon or something like that. But it is one of these examples that tends to show up in an interview, and you're meant to write sort of pseudo code. And even though today we'll actually be developing using TDD, the FizzBuzz algorithm, the approach that we will be taking, the sort of iterative approach, you can actually use on the whiteboard as well to sort of build out your FizzBuzz problem. So why don't we do that now? So the idea is to sort of kind of from 1 to n and have the following rules apply to the FizzBuzz problem. Okay, so if a given number is divisible by 3, instead of printing 3 or 6 or 9 or whatever it is, we will print fizz. If the number is divisible by 5, we will output buzz. And if the number is divisible by 3 and 5, it's FizzBuzz. And for any other kind of number, we will just print the number. So just to run through sort of a few steps, if it's 1, we end up with 1. If it's 2, 2, 3 is divisible by 3, so it's fizz. 4 isn't divisible by 3 or 5, so we're back to just a number. 5 is buzz. 6 is once again divisible by 3 is fizz, and kind of so on. 9 fizz, 10 buzz, and then up until 15. 15 is sort of the first number that's divisible by 3 and 5, so that becomes FizzBuzz. And then the next one, 16, isn't divisible by either one, so we just go for 16. So we'll be developing that today, and I've got my Visual Studio open already. So I'll be using C#. I've got a Kata solution where I develop these kind of examples. I haven't got one for FizzBuzz yet. So let me just kind of add a file. Oops, no, not that. I don't want to add in NuGet packages. Just try that again. So add a new class. And I'm going to be calling this. So it's a little bit slow. I'm not quite sure why. I'm going to call it FizzBuzz tests. All right, there we go. I have in this particular solution or project, I've already included XUnit and also Fluent Assertions, which is a nice sort of testing framework for the assertion part. Let me just make that public. I don't want to run into any issues. And all right, so we're going to write our first test here. We have to have, as per rule number 1, we have to have a unit test before anything. Okay, so we can't even have the class. Okay, what kind of test should we write? Well, oops, just include XUnit. Lovely. So how about we go public void, oops, can call, oops, fizz buzz underscore calc or something. All right, so there will be a FizzBuzz class, and it'll have a calc method, say, and we can call that guy. Okay. Probably not going to make that an instance method, an instance class. Let's make it a static class. Normally wouldn't do that, but given this is such a deterministic kind of output, and we're only going to have the one version of it, there's no need to have multiple instances. We might as well do that. Okay, cool. So let's go FizzBuzz, not buzz, FizzBuzz dot, no, not test. Sometimes the IDE helps too much. .calc. Alrighty ho. There we go. We have written our first test. We've got a compilation failure. The IDE is saying, hey, I don't know this particular class. So why don't we create it? Public static class, and we're going to call it FizzBuzz. Okay, lovely. All right, it doesn't know the calc method, so let's do that at the same time. Let's kind of say public, and for the time being, obviously it'll return us something, but for the time being, why don't we just kind of say it's a void, and it's not going to take any parameters either, although later on it will. We just want to make this guy pass. Of course, it needs to be static. Lovely. Okay, so we have written a test that forced us to create the class and the method. There really isn't any point running this, but if I wanted to, because there was no further assertion here, it ought to pass. Okay, it's just thinking, here we go. It's coming up as a success because there was no assertion. And this is a test that we're just using to stand up the class and the calc method. It's a scaffolding test, and we can delete that later on. It really will play no further part in developing the logic. All right, why don't we move on to the next test? So the next test is going to be, what are we going to make that? Void. Well, what if we take a 1 as a parameter, right? I mean, that would make sense. That we're starting with 1, and I think from the particular sheet that we saw there earlier on the slide, it kind of said, well, when we intake a 1, we will output a 1 because a 1 isn't divisible, cleanly divisible into an integer by 3 or by 5. So maybe something like given input is 1 or something like that, when call calc, FizzBuzz calc, let's call it that, FizzBuzz calc. Yeah, okay, there we go. Nicer. Then return 1 as well. So I'll just kind of do that. Right, lovely. And we're going to have a bar result or something. My output is equal to, well, FizzBuzz calc. FizzBuzz, here we go, FizzBuzz.calc. And we're going to pump in the 1. And it's not, it doesn't like it. We can do assert equal 1. I like the fluent assertion, so I'm going to use that. I'm going to say result dot should dot be, and I'm just going to make it 1. We do know that ultimately we will have to kind of go the string way, but you know what? I'm going to play it like as if I had a memory of a goldfish, and I don't remember that. So for the time being, let's just make it an integer. So when we put in 1, 1 isn't divisible by 1 or by 3, we will get a 1 back. All right, nice. Well, we've got a few compilation errors to fix. Well, the first one is maybe that we're taking an integer in and input. All right, that's helpful. And now it's complaining because it's not returning anything. Why don't we make that an int as well? Okay, and up here it's complaining we don't want to maintain this scaffolding test. We can delete that. It's okay to delete unit tests. Sometimes they have outlived their usefulness. We should just get rid of them. Okay, cool. We're not quite done yet. Calc is saying, hey, I want you to return something. That's correct. So let's just kind of go, I'm going to return 0. I'm not going to return a 1 just yet. I just want to see that the test is sensitive to failures. Right. I mean, I'm pretty sure it will be because it's such a simple thing, but it's easy to write a unit test that always passes. So I would like to move on from, okay, lovely. We've moved on from the compilation failure to the runtime failure, right? It's kind of saying, hey, I expected it to be a 1, but I found 0. How do we fix that? Well, let's return the 1. Run all the unit tests again. Run that unit test again. Bang. It's passing. Right, next one. In a similar manner, I'm just going to copy that guy. Fortunately, I'm too slow a typer but I will with copy and paste. I mean, I'm okay with that, but then I do go through everything with a fine-tooth comb. Okay, so when we return 2 results, so put in 2, and the result should be 2 as well, right? So let's kind of do that. All right, excellent. So 1 unit test passes, that one up here, the one down here does not. And it's saying, hey, I expected a 2, but actually I found a 1, which makes sense, right? Down here, we've got a 1, and we always return a 1. How do we fix this? Well, we always seem to be so far returning the value that we're inputting. Okay, so a really simple way to fix this unit test is by saying, hey, why don't we just return what's come in? All right, excellent. Let's give that a go. Run through this. Bang, it's all passing. All right, let's go to the next guy. We'll turn this soon into a theory, which is a parameterized unit test. I feel that we're not quite there yet, nearly, but not quite. So let's just do it after. Let's do some refactoring of the unit tests after this unit test. So we're going to go, okay, when input is 3, then it should return, so 3 is divisible by 3, so it should return fizz. Lovely. So we're going to go 3. And then, right, so now this will be interesting. Fizz. And it's saying, well, okay, we actually expected a integer here, but you're returning a string. So we will need to make a change. We will need to return a string. Okay, the input is in the string, and up here we don't have strings. Okay, I think it would be reasonable for us to turn these into strings. Okay, move the All right, 2. Yeah, that's good. Input. Well, let's turn the integer into a, okay, there we go. Lovely, 2 string. Let's just see whether 2 out of 3 of our unit tests are passing. Should be. Okay, good. One of them is failing because it said, hey, it received 3, not fizz. Okay, we need to fix that. What's the best way of fixing that? We could kind of say, put a little conditional before we return. So if input is equal to 3, all right, we're not kind of really simple, not doing any, if it's divisible by 3, modulus or anything like that, not really, really simple, then return fizz. And, if you had to do this on the whiteboard, you could have done it in the same way, kind of writing out what the FizzBuzz function or method would have been like. By kind of going, well, right, initially return 1, then we return whatever the input is, because, when it's 1 or 2, we expect that. Now we need to introduce a conditional for 3. And then we kind of see how we go for 4 and for 5 and so on. So let's kind of run these. Hopefully this will pass. Lovely. It's all passing. Let's go and do some refactoring. I'm okay with what we've got down here for now. So let's leave the production code. But our unit tests start to get a little bit cumbersome. So what I'm going to do is I'm going to turn these into theories. Here we go, lovely theory. And then get rid of that. And we make these inline data. And we're kind of sort of say, hey, let's specify the input and the output. When it's 1, we expect 1 to kind of come back to us. Okay, lovely. And we're going to say, hey, given input, okay, no longer is 1. So we're going to make that a little bit more generic than return output, maybe. Okay, lovely. And the input, let's call it int, will be input. And string will be the output. All right, lovely. So let's just make the appropriate replacements. Oops. Output. Okay, let's just make sure that's still passing. It's really only just testing 1 still. Okay, and it's passing. Lovely. And so let's move these other tests up here. So when we've got 2, we expect it to be 2. And when it's 3, we expect it to be fizz. Okay, so run these, and if this is working out, okay, lovely. So here we go, we can split it out. That parameterized unit test, we will see that input is 1, output is, string 1, inputs 2, outputs 2, inputs 3, outputs fizz. Lovely. We can remove these other tests now, which is great. Cool. And by the way, for the time being, I don't mind our implementation, our unit tests being in the same file. I know you start out like that when I do TDD, and then later on I start separating it when it gets a bit unwieldy. But FizzBuzz is such a relatively simple problem. It's easy enough to do. Okay, what about, let's kind of continue with 4. So if we have 4, then we should get a 4. 4 isn't divisible by 3 or 5. So hopefully this will work without us having to make any changes. Lovely. Okay, now it's going to get interesting because we are going to do, next we're going to do 5. Inline data. And we're going to go 5. And of course, now we are expecting it to be buzz. Is that going to work? Well, no, that isn't going to work. It's failing. It's saying, hey, we expect it to be buzz. However, it was 5. Yeah, correct. It was 5. Right, how do we fix that? Well, maybe we could introduce another if. So if input is equal to 5, then return buzz. Okay, oh lovely. So let's run that all the tests again. It's easy enough to run them all. Let's make that a little bit simpler. Remove some of these. Okay, excellent. Now it's getting interesting, because when we're going for 6, we are having another number, another input where we would want to have fizz. Let's run that. We should get a failure, and we do. Okay, it says, hey, you know, we got 6. Right, so we'll need to fix that. And what's a good way of fixing that? We could kind of say, hey, if input is, you know, 3 and 6 and 9, but of course this is going to become tedious. We will need to come up with a better way of handling that. And the way to do that is by saying, it's using the modulus operator. So if modulus 3 is equal to 0, then make it fizz. So basically that means there will be as a remainder of 0 when we divide by 3. So that applies to 3. Divided by 3 will be 0. If it was 4, the remainder will be 1. If it was 5, remainder will be 2. 6, remainder is again a 0. Okay, so let's run this guy up. Lovely, all passing. Okay, we could go for 7 and 8, and they would pass. Oh, you know what? That's so easy to do, and it kind of keeps the chain intact. So I might just quickly do 7 and 8. All right, and I am so confident that that's going to automatically work. The 2 of them in one go. Naughty, naughty. All right, look, all green, lovely. Now 9. 9 is interesting because 9 should be a fizz. All right, and then 10 will be interesting. 9 will be a fizz. That should now work. Lovely as well. Okay, and 10 will be a buzz. All right, it should be anyway. 1, 0. We might see a failure. And by the way, it's okay for the unit test to pass, you know, automatically, or with the code that we've already written. That's okay. And it's okay to have a little bit of extra data in here. These things are so fast and they run so quickly, you know, they don't have to like go to the database and it takes hundreds of milliseconds, you know, or even longer. These are inside, you know, like microseconds. This is executed. With these unit tests, we should be able to run thousands of them inside, you know, 10 seconds, and it'll be just fine. So it's okay. They do not use up a lot of resources. Obviously, here we go. Expected buzz, but found 10. How do we fix that? Well, in a very similar manner to how we fixed the one above. Oops, there we go. Okay, and that's now working. All right, we haven't come across a number that divides by 3 and 5. I'm not going to do 10, so 11, 12, 13, 14, but we do know that 15 divides by 3 and by 5. So 15 should give us FizzBuzz. Let's give that a go. There we go. Yes, it does. Expected FizzBuzz, but was 15. All right, not quite what we want. What if we, how do we fix that? What we could do is we could underneath here, I'm going to make a little bit of a tactical mistake. Can I say, hey, divide by, you know, modulus should be, modulus 15 should give us a remainder of 0, and we'll make it FizzBuzz. Okay, this is not going to work, as you can probably already see. So, oh, okay, I didn't fix the problem. Why is that? Well, because it's going to come in here first and check, you know, it's going to output fizz, which is what it did. And so this is a more sensitive condition, and therefore we would we need to check for it first. Right, oops, like that. So we want to check for modulus of 15 before we check 3 and 5. Hopefully now we're gonna be fine. And at this stage, it is useful. I sort of like to throw in another 3 or 4 what I call forward-looking tests, okay, where we put additional unit test data into, as an input, and we will not need to change our implementation code. Okay, so what might be useful? It would be nice to sort of test another buzz, FizzBuzz. So maybe I'll make that 30. Yeah, that should be FizzBuzz as well. Lovely. And maybe we'll make it what would be good as well. I know that 41 is a prime number, so it doesn't divide by 15, 3 or 5. So we should just get the number coming back there. Okay. Great. And maybe, okay, let's go for another kind of fizz and a buzz and a FizzBuzz. Maybe a fizz, well, we would look at maybe 93 would be a fizz. That's divisible by 3 and not 5. Maybe 100 would be buzz, and maybe 435 would be a FizzBuzz. Okay, let me kind of, yeah, should be divisible by 15. Okay, lovely. And then one more for just to make absolutely sure. I know that 1024 is just the power of 2, so therefore that'll be fine. Just to kind of, I'd like to provide some larger numbers just to sort of indicate that it will not stop. It'll work whatever number you pick. As it stands right now within the sort of integer range. Okay, lovely. And we've developed FizzBuzz. And of course, one of the lovely things we can do now that we've got these unit tests, we can move things around a little bit. We can now refactor the calculation of FizzBuzz, which, by the way, isn't even too bad. But if we wanted to kind of change it around a little bit and kind of say, well, maybe we could have done it a bit different, maybe because var output, output is equal to, maybe we can say empty string. Let's kind of start with that. Let's kind of build up FizzBuzz, and we can kind of say if input is through, so then maybe we can kind of say, hey, we can, so output is equal to plus equals output. So we'll append fizz. Okay, lovely. And here we kind of say, well, if it's divisible by 5 as well, then maybe we can add buzz onto it. So it won't come in here if it's not divisible by 3, divisible by 5, sorry. And then maybe we can kind of say down here, if, because we will need a conditional. So if output, guess we will need that. If output is still empty string, then we'll just return the number. Yeah, okay, that'll work. So we didn't come in here and append fizz or buzz, else we return output. I think that might kind of work. Okay, hold on, let me just, it's not really any shorter. Okay, lovely. So it all still passing. So if we deem this to be a better algorithm, maybe it is. So we can kind of do that. Yeah, that'll work, I guess. Let's try it again. I mean, it's fantastic to have these unit tests, and there you go. They're all passing, and FizzBuzz is all working. All right, let me kind of come out of here. And are there any questions?
I think it was a really good one to see all of that. Uh, my question probably would be just thinking from the what I was trying to also understand the same way is because now we have the the outputs that you have already shown us. So this is the expected result. So we go based on um, those expectations. Those what we will be expecting the output. So what I was thinking is how we can, when we implement the same concepts, same approach in writing an API, so like using a cloud operation, um, then how can we follow the similar approach? So how we can think of like the what are the expected tests, basically say like a test case, like how you have started by given this one input, this is the output as one, then you went to and then you have some examples that you can refer to. So similar that approach when you think from those sort of test result, expected test results. So same like there was the response from those API endpoints, you know. So I was trying to get that, how I can use those. So if you have something because this one was just very, especially you have the numbers, you go start with 1 2, you come to the case 3, and then you have a 5 and 15, you know. So I was thinking like how we can do sort of similar, uh, like because now the approach what I'm doing, what I do when I write my APIs, I write APIs and then the test. That's the approach we're going, and then and just basically seeing are those covering all the scenarios. That's what I test for. Um, I just go and look at the implementation code and then say, okay, is this conditional block it's been covered? No, then I go and write the test for that. So I was thinking how I can start this same approach when I write the API. So if you have some sort of suggestion on that, I think that would be good. Uh, like how I can cover most of the cases, I would say. Like I'm obviously covering how I go normally is I just look at the main sections, main blocks, main conditions, and then also look the coverage, the test coverage as a line wise. It says that which lines you have covered, but also if you have any advice on what we are better to when you write those APIs, the same way, so that you don't miss any sort of important test case. So that would be good.
Yeah, it's a good point. This is obviously a almost a trivial example of an algorithm, and for that reason, it's only used like in interviews or like in hackathons or that kind of thing. It's when would you ever need anything quite like that? And same with the bowling. The bowling game or the Fibonacci sequence. These are great sort of like algorithmic exercises we can, that are often used as a show TDD. I find that they're not realistic. I have got a workshop, a 2-day workshop where we do kind of two things. One of them is we sort of write a shopping cart type implementation. So this is like a domain entity that's got actual logic that you would use in like an e-commerce website or something like that. And the other one is, okay, we're going to write a business logic workflow. It's called a use case. Okay, that does something non-trivial, like registering a customer against the database. But of course, you wouldn't, using TDD, you can't actually go against the database. You'd go against some sort of abstraction, like an interface. But when it kind of then comes to all right, now this use case, we want that to be hosted in a web API or something like that. Now you are, because you've already written the use case, which is like the core of any application or of any particular workflow, should be this thing that is just about what happens, not how it happens. Here are the steps that need to happen in order to register this customer. We are not saying we're using a SQL Server database. We are not saying anything about HTTP. It's just business logic, just what we're doing, not how we're doing it, which means you can embed it in outside of a web context as well. You can use it in a mobile app, you can use it in a Windows service, in a AWS Lambda, whatever it is, which is lovely. Then when you know how the main business logic reacts to faulty input, for example, you're not specifying the first name for the customer, and this is a problem, you can expect a certain exception, okay? And that exception in your API, you can then kind of recast that as a 400 bad request or something like that. So you can kind of say, hey, when I get these exceptions from this main thing that does the business logic, that are really not too interested in how it does its job. I'm just interested in whether it succeeds or how it fails. And if it fails, I will catch those failures here and I will return those as 400 bad requests, or if it's something to do with authentication and authorization, it'll be a 401 or 403 or whatever it might be. You know what I mean? So that's how you would go about writing your API. But you ought to first look at writing your business logic, okay? Because if you write your controller action first and foremost, and there's like, the database in there, and all this web stuff intermixed with, maybe presentation type stuff. Oh, this is coming in as JSON or re-emitted as XML. Now things get hard. Now writing TDD all of a sudden has become so much more complicated. It is really important to kind of start from the inside and then move with the business logic and then move out to the to other concerns like database or data access anyway, or like web or your API. Does that make sense?
Yeah.
And maybe to a degree, we can kind of do some of, I actually want to interact more with developers. I love the business side of things, but I want to interact more with developers and kind of show these kind of sides of TDD, with you guys. So I'm looking to do more of this with more people. That would be great. Yeah.
So maybe focusing more on the business logic use cases, and just writing the test mainly for those ones, because that will always remain that same no matter what other different layers like database or the front-end presentation layer changes.
Correct.
Right.
Because when, say, for example, you've got some business logic that says employees get paid every second Wednesday, does it matter that you've got a SQL Server database? No, it's irrelevant, right? Does it matter that maybe you don't even have a database? Maybe you're writing to a file system or to it's not SQL Server, it's like Cosmos DB or something else, It just doesn't matter. When you're paying employees every second Wednesday, you're saving something to somewhere, but you wouldn't be specifying what the mechanism is, the data persistence mechanism. So if you write that on the inside first and then further out, everything then becomes pluggable.
Yeah. Cool. So just one more question on top of that one.
Please.
So with the use cases, business logic, obviously we just with the general understanding, we start sort of testing with the happy sort of path, right? So when you give certain this values which are mandatory and register users, right? But also, how do you think of the different sort of scenarios and on a happy path? And we can take an example of this FizzBuzz or an API. But how do you normally sort of think that, like, not just only thinking, okay, with this one function or endpoint, you're just testing that, okay, get all the customers. It's a gate. It's getting all those customers, basically list. Get all customers sort of function it as, and you now start testing. Not start writing tests, but you, even before writing the production code, you start writing the unit test, right? Going from the TDD sort of. So that's what I want to actually implement in my work itself. So how do you sort of think from, so if you have to write a function which get all the customers, now you're starting TDD. So what would be your approach? Obviously, you will have a one test which will say um, get all the customers, but is that all the test you will want? No, right? Because there's different sort of scenarios. So
Yeah, it's a really good question, Kamal. And there was actually another slide which I have removed because I knew there wouldn't be enough time to cover it in this 1 hour. But it is also part of the TDD that I do in my day-to-day work with companies, and I want to do it more with developers. It's the slide of what's called the thorns and the gold. Okay. And have you heard of those terms before?
yeah.
You've heard of the thorns and the gold? Okay.
Yeah.
So the thorns, okay, are it's sort of, think of Indiana Jones. Okay. It's got an Indiana Jones feeling to it. And if you think of that, you'll never forget it. So in order to get to the gold, you will have to cut the thorns down first. Because the thorns will snatch at your clothes and you can't get anywhere. Okay, what are the thorns? The thorns sort of come in three kind of flavors, but the worst, well, the ones that we really want to cover, the ones that are usually the kind of worst thorns, if you will, are exception or error scenarios. Okay, we want to deal with error scenarios before we go for the gold. The gold is the happy path. Okay. So imagine when you're writing your unit tests and you're developing this sort of small set of classes that are working tightly together. Okay. And you are dealing with all the error scenarios first. You're going to get, and usually, you know, I mean, so not usually, always, the error scenarios are very finite when you're working. So it's like, oh my God, we're going to end up with so many errors. No, when you're writing unit tests, you end up with a very small number of scenarios. Okay, like with a shopping cart, you might have no product. So product is null in C# and in TypeScript, you wouldn't get that. And maybe you have an invalid quantity. Quantity can't be 0 and negative. Okay, cool. There you go. That's it. That's the only, when you're trying to add something into a shopping cart, those are the only two things that can pretty much go wrong. So when you deal with those first, you end up with a rock solid shopping cart implementation. You know, when it gets these error conditions, and you're dealing with them before, and you're dealing with them well, you know, before you get to the happy path, all the hard work's been taken care of. Okay, and you end up with a rock solid overall application as well, because when your small set of classes that are the unit integrating with the rest of the application, and they are unstable because when they respond badly to invalid input, they will throw a null reference exception or something like that, you know, and it's going to be a problem. Now you have this null reference exception, you know, traversing your system, you know, while if you've dealt with it well, you know, and it's going to be, this exception is going to be thrown, it's of a particular base kind of exception, which is caught at a particular level and then dealt with. Now, all of a sudden, you know, you have the basis for a rock-solid application. Oh, what did he say? He said he liked that? Okay, cool. Oh, well, you're welcome. Yes.
Yeah, no, I think that makes sense. I think so. Yeah, normally when I start with the happy path test and then look at the other scenarios and all those HTTP response codes of different error, you know, service error, bad request, and all those. But I think I will change the way I think now. Yeah.
Good man. Good man.
The other way. Yeah. Now that I think that makes sense. That makes sense because that's what you want to capture first, and also it's from the practice. I think it's good because the happy part it will just go well, right? There's nothing to, even if you like say if you miss one test for the happy part, it's going to pass. It's going to success. Right? But what you want to capture is the that's the whole point, right, of the unit test, because one of the advantages is to easily find a bug is and because the test will fail, and then you find out okay, this is where the because this implementation code was changed, that's why this test has been failed. So that's one of the advantages of unit tests. So I think that's where it adds more value, starting from the unhappy parts and the thrones you mentioned.
Unhappy paths.
So,
I like your wording. Yes, it's the unhappy paths.
yeah. So I think and that's I think where I'm going to. So that's what I'm practicing now with my microservices, all the APIs, is the TDD sort of way. Even if it's to start with, it might take some time to just to get hands on and just to get a bit of used to with it. But because you want to see the actual value and you want to see the advantage of it, you just don't want to write the unit test just for the sake of writing a unit test and just covering those line and just because it's a requirement to write unit test. So that's what I want to make actual use of it.
Yes.
And also sometimes I realize that when I write implementation code, go and write a unit test. Most of the time I go back and refactor my implementation code, because I feel like this is not needed, or this can be done this way. So why not start from that will save so much of your time if you start from the other way around. Then why not go to do that practice? So I think
that's very valuable. Now, I mean, you
yeah.
definitely want to use the refactor step, because
Yeah.
I mean, at first it's all about just making it work. Okay, I mean, still with the sort of intent of writing as little code as possible, and then you make it kind of nice and short and concise and easy to read, and you refactor. If there's too much happening, maybe you can extract some of it into a little helper method so that your code, which is was like 15 lines long, and that kind of comes back down to something more reasonable, like 5 or something. Maybe there's a lot of validation code had kind of accumulated. It's a good idea. I will need to go, Kamal, because it's I've got 8 o'clock here. Thank you very much for turning up. Okay, I think that's lovely. It's good to see you again. All right, cool. Bye-bye.
Thanks for running this session.
It's all good. Thank you.